Welcome everyone. In this video we will solve an interesting integral. Let me write the integral. The integral is 1 over x to the fourth plus 4x squared dx. Why don't you pause the video, try to do it on your own, and when you're ready, continue the video please. Okay, I assume that you gave it a go or you simply want to see the solution. So in any case, let's get started. The first thing that I will do is to factorize the denominator. So we have 1 over, I factor out the x squared plus 4, then you have the dx. Here you can see that the integrand, the thing that we are taking the integral of, is a rational fraction. It is basically, what is a rational fraction, you might be saying? It's a rational function actually, maybe that's a better way of saying it. It is a fraction because on the top you have a polynomial 1. I mean all the terms with x have coefficient 0, but it is still a coefficient, it is still a polynomial, and in the denominator you more clearly, as you can see, have a polynomial. So we have the ratio of two polynomials, which is a rational function. And there is a method called partial fractions, which allows you to write a fraction in terms of the sum or difference of other fractions. And we want to write something else for this because right now by looking at it, we are not able to take the integral. But if we can separate this into maybe 2 or 3 fractions, then we might be able to take the integral of those parts separately and then basically add the integrals. So let's get started. We will have 1 over x squared plus 4. Now there is a setup for this, and if this is the first time that you are seeing partial fractions, I don't get that. I don't assume that this will be obvious to you. You might not get it at first, at least for me that was the case. So I would recommend that you watch other videos on this, do some research, or if you want, write that in the comment section and I can make a separate video on this going over the method. But for the people who know this, you know that we can write this as ax plus b x squared plus, cx plus d over x squared plus 4. You could have also, you could also do this. Let me write it real quick. And I won't use this one, but you can go over this on your own and convince yourself that this works as well. So the setup in yellow would also work, but I will be using the setup in blue. I'm not sure if it is blue, but whatever it is. So I will make all the denominators the same, which means, so I will multiply this guy by x plus 4, and this one will be multiplied by x squared. And since the denominators are the same, I will just write the numerators. I will get rid of the denominators. We have 1 is equal to ax plus b x squared plus 4 plus cx cubed plus dx squared, which means we have, ax cubed plus 4ax plus bx squared plus 4b, and then the other two terms. Right now we will use what is called, I guess, the equivalence of polynomials or something like that. And that basically says if two polynomials are equal to each other, the corresponding terms should match. So the coefficient of x cubed in one polynomial should be the same with the other polynomial. And looking at that, we see the constant term for the polynomial on the left is 1, which is the only term. So 1 is equal to, what is the constant in this polynomial? It is 4b. So 1 is equal to 4b, which means that b is equal to 1 over 4. Cool. And now let's consider the coefficient of x cubed. For the left, that is 0. For the right, we have a plus c. A plus c, okay. For x squared, let's say it is again 0. Excuse me, for x squared we have b plus d. They are the two coefficients. And if we consider the coefficient of x this time, it will again be 0 for the left side. And for the right, it is 4ax. Oh, this means that, not ax, excuse me, 4a, right? The coefficient of 4ax is 4a. So a is equal to 0, which means from this equation c is equal to 0. And also this one shows us that b is equal to negative d, so d is equal to negative 1 over 4. Since b is equal to 1 over 4. Well then, we are able to express this rational function as the sum of two ratios. I am just using this formula that we started with. We will have for a it is 0, for b it is 1 over 4, so 1 over 4x squared. C is 0, d is negative 1 over 4, so minus 1 over 4 x squared plus 4 dx. And let me erase this part, we don't need it anymore. Okay, and also you can see that we made this separation correctly by simply combining them under one denominator. And I mean, maybe we do it real quick. So we multiply this by x plus 4 x squared. So it is x squared plus 4 minus x squared, which gives you 4. The 4's cancel, we get the initial one. Cool. Now continuing on, I will take the 1 over 4 out of the integral. We have 1 over x squared minus 1 over. Now for x squared plus 4, I will write this in a way that is more convenient for us to be able to take the integral. I will write it as, let's see, 4 is factored out x over 2 squared plus 1. Is this right? Yes, it is right. You have dx. Well, 1 over 4. What is the first integral? So 1 over x squared dx, that is going to give you negative 1 over x. Now for the second integral, I wrote this in this format because remember that the integral of 1 over x squared plus 1 dx gives you arctangent x plus c. This is in the form of that. So only for x we have x over 2, which is not that big of a problem. We write minus. It will be something like arctangent x over 2. But now let's see if we missed any factors here. Let's take the derivative of this. It will be 1 over 2, the derivative of the inside, times 1 over x over 2 squared plus 1, which is 1 over 2, 1 over x squared plus divided by 4 plus 1. So I need a 1 over 2 factor to have the original one, which means I basically divide by 2 here, then add the plus c. If we make this cleaner by factoring out the negative sign, this is the result for the integral. Let me write it. Okay, cool. This is our result. Anyways, I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.